Hi, everybody. Welcome to my channel, Numbers with Nora. This is a math tutoring channel that helps with all your math questions, homework questions, and all your math needs. For this specific video, I'm going to be doing Algebra 2, and I'm going to start with Common Core Unit 1, Algebraic Extensions Review. Okay. Oops. I don't know why that's spelled wrong. Algebraic Essentials Review, and this is going to be lesson 1. We're going to go with variable terms and expressions. All right. So this is more of like a review from Algebra 1, but we're going to get into the Algebra 2 stuff as I go farther on in the units. Again, I'm using the Common Core Algebra 2 Mathematic Instruction book. I'll put the link for this book in the description for this video. All right, let's get to it. All right, so variable terms and expressions, Common Core Algebra 2. So like I said, we're going back into Algebra 1, and basically these are the basics for sitting there and solving basic algebra equations. So I know a lot of you guys have heard of PEMDAS or GEMDAS. I usually do PEMDAS. All right, so P, parentheses, exponents, multiplication, division, addition, and subtraction. This is like what we should follow when we're sitting there solving math equations, okay? And there's also terms that we need to know, right? So variables are things that are unknown in mathematics. Usually we use letters to sit there and say something that is unknown or a quantity that is unknown to specify how to find that is used with A, B, C, D in our expressions. Terms are a single number, a combination of number and a variable in a algebraic expression or equation. And I'll sit there and point one of those out as well later. And an expression is basically an algebraic equation without the equal sign. So if you see something without an equal sign, like the one below right here, that's more of an expression. Now, if I was to set this equal to a number or another variable, then it would not be an expression anymore. It would be an equation. Okay. So exercise 1, consider the expression 2x squared plus 3x minus 7. How many terms does this expression have? So I like to sit there and consider terms as two things that are being multiplied or one thing that stands alone. And what sits there and separates them are my addition or subtraction. Okay. So here I have 1 term, 2 terms, 3 terms. Okay. So the answer to A is going to be 3. All right, so B, evaluate the expression without your calculator. When x equals -3, show your work. Again, we're just going to use substitution. So everywhere where I see an x, I'm going to put a -3, okay? It's going back to Algebra 1, just basic substitution. And I always use parentheses when I use substitution, -3 in parentheses, squared, plus 3 in parentheses. So everywhere I see an x, I put a parentheses and a -3. And then minus 7. Okay. Now, again, I'm going to sit there and use PEMDAS again, right? Parentheses, exponents, multiplication, division, addition, subtraction, to sit there and work through and solve this. So when I work through and solve this, the first thing I'm going to do is I know I have parentheses in here, but the first thing I'm going to do is my exponents, right? So 2, -3 times -3, that's going to give me +9. Negative times a negative gives you a positive. Squared. Now I can go ahead and do, oops, sorry. Why did I put squared again? So we're getting rid of that square. Then here, 3 times -3, that's going to be -9. Now I'll just put that in parentheses and then minus 7. Go ahead and work this out again. 2 times 9 is 18. That negative is going to win over. That's -9. And minus 7. Again, I move from left to right in solving. 18 minus 9 is 9. minus 7. 9 minus 7, that's going to be 2. My answer for this is 2. So this one is really just using our laws, our PEMDAS rules. Okay. All right. Just box all our answers here. And for C, what is the sum of the expression with the expression 5x squared minus 2x plus 2? So we're adding these two expressions together. So to write this one out, I'm just going to put 2x squared, the expression they give us, plus 3x. And then minus 7. And they said the sum, so sum means to add. And notice I put the second one that I'm adding, I'm going to put it in parentheses because sometimes when we subtract them, that means we're going to have to use the distributive property and distribute that negative through, or even if we're multiplying by something, we're going to have to distribute through. So I'm always trying to be safe by sitting there putting the parentheses. So minus 12x and then plus 2. Okay. All right, so let's go ahead and add these through, right? I can take those parentheses away. No, I'll keep them there for now. Sorry. All right, so now I just want to sit there and combine my like terms, okay? And we're going to sit there and see what like terms look like below. But like terms are anything that has a variable that is the same or the constant that's the same. So I have this x squared that's the same, and it has the first term of 5 and 2. I'll do it in different colors so we know. I have another term, like terms, that have the same x variable, 3 and negative 2. And then my constants are left over, right? The negative 7 and 2. So I'm just going to combine my like terms. So 2 plus 5, that's going to be 7x squared. And then I have 3x plus or minus 12x. 12, 11, 10, 9. That's going to be minus 9x squared. Or 9 minus 9x, sorry. And then negative 7 plus 2. I do negative 7 plus 2. That's going to give me negative 5. Right. And that's where I finish. I can't combine any more like terms because 7x squared, that has a different variable than the 9x, the negative 9x. So I can't combine those. Okay. And this 5, that's just a constant. I can't combine that. So that's as far as I can go with simplifying that expression. Right. So next, let's go on to like terms. Excuse me. All right, so like I said, with like terms, when we combined our like terms, they're terms that have the same kind of variable. So if I had a 2x, just as an example, plus 3x, I could combine these, all right, because they both share the same variable, okay? They're both to the first degree, okay? So I could sit there and add my constants, my 3 and my 2. Or and sometimes they call these your coefficients, okay? I can add my coefficients together. Oops. So I would get 5x. Right? So I'm just adding my constants together, and that's like what I'm doing to get my like terms. And if we just glance at this below for exercise 2, I have 4x squared y plus 6x squared y equals x squared y, and they sit there and pulled out the 4 and 2 to combine. I could do this because if you look at my 4 as a constant, and these are its variables, they have the same variables, x squared times y, x squared times y. I could sit there and combine my coefficients. Okay. So that's pretty simple in that way. Real number properties, we saw this as well in Algebra 2, and I'm just going to run through this very quickly. If you have more questions on these, again, leave a comment. The commutative property of addition and multiplication. Notice that commutative can only be done with addition and multiplication. It cannot be done with division and subtraction, okay? So commutative is when we sit there and we're able to switch our terms, right? So a plus b can be switched to b plus a. Same thing with a times b can be switched with B times A. Okay, so you're just switching the order. The associative property of addition and multiplication. For this one, I'm just switching on what I group together. Okay, so right here, I group my first two terms together. But then right here, I group my second two terms together. And this, again, could only be done with multiplication and addition. The distributive property, this is when we sit there and have something being multiplied by my parentheses, and it has to hit every term within my parentheses. Okay, and that's called distributing. And so we can go ahead and see what that looks like in exercise 3. I'll sit there and pull out a text box so we can sit there and do this one. All right, so in exercise 3, the procedure for simplifying the linear expression 8 in parentheses 2x plus 3 in parentheses plus 5, start parentheses 3x plus 1 in parentheses is shown below. State the real number property that justifies each step. Okay, let's go ahead and see. I'm going to go ahead and draw text boxes here. All right. So for this first one, we sit there and notice here. There we go. It's gonna let me draw again. I'm sitting here. I always like to sit there and draw when I'm using the distributive property. This 8 has to hit every term within my parentheses. Okay. And as you see here, that's what they did. The 8 times 2x, 8 times 3, and then the 5 times 3x, 5 times 1. What they're doing here is called the distributive property. Okay. Good. And then here, let's go ahead and do this one. So next, we want to sit there and see what they're doing. Right here, it kind of looks like they're grouping together our terms, right? So when we sit there and group together our terms that we're going to use, all right, we're sitting there making associativeness. So we can sit there and say associative property. Just like grouping together what we want to use, right? All right. And then let's do the next one. For this one, after we sit there and figure that out, we sit there and change our terms to be together, right? So when we sit there and like change our terms to be together, I could say this is a, do I want to say commutative? We're switching our terms around, right? We're switching our terms around right here. That's commutative. And we could do that because it's addition. If it was subtraction, we would not be able to use the commutative property. So commutative property. Okay. And then our next step right here. This one is going to be combining like terms. Right. Because we sat there and pulled out this x, we're combining our constants 16 and 15. Again, right here, this is another one. We're combining our like terms. Okay. And then we arrive at our answer right here, 3x plus 29. We cannot combine these because 31 and 29 are not the same terms. 31 is being multiplied by a variable x. Okay, so that's where we stop. All right, let's go ahead and look at this last one. Because we use the real number properties to transform the expression 8 in parentheses 2x plus 3 in parentheses plus 5, start parentheses 3x plus 1 in parentheses into a simpler form, 31x plus 29. These two expressions are equivalent. Remember, equivalent means the same in mathematics. How can you test the equivalency? Show your work. For this one, I'll do in a text box. To show equivalency just basically means that they're equal to one another, okay? So how I'm going to show this is I'm going to set these two expressions equal to each other. and I should get a true statement, okay? This is 2x plus 3, and then plus 5, 3x plus 1, okay? Set them equal to each other, and now I just start to solve by using all my expressions and stuff like that that I learned out there. First thing I'm going to do is I'm going to sit there and distribute. Let's see if it will let me draw on here. I always like to annotate my work as usual. So I want to make sure that 8 hits every term in those parentheses, and I want to make sure the 5 hits every term within those parentheses. Okay, so then I'm going to get 31x plus 29. That just comes along for the ride right now while I distribute. So then I'm going to get 8 times 2, which is going to be 16x, plus then 8 times 3 is going to be 24, plus 15x, plus 5. Okay. Next thing I want to do is I want to sit there and start combining my like terms on this side. Let's sit there and do that here first. So again, that 31x plus 29 just comes along for the ride. And then 16x plus 15x, that's going to give me 31x. And then plus 24, 25, 26, 27, 28, 29. All right. Now I want to sit there, and if I sit there and I want to combine all my like terms again. So notice if I subtract this 31, sorry, I don't know why my computer's acting like that. If I subtract this 31 from both sides, they're going to cancel out, okay? So I could say that's going to cancel out. So now I'm just going to get 29 equals 29, which is a true statement, all right? So since I got a true statement, that means that these two expressions are equivalent, and that's how you can check for equivalency, okay? If I got a false statement like 0 equals 29 or 1 equals 29, then those two expressions would not be equivalent, right? My next video for Algebra 2, I'll sit there and do a lesson on this as well and do some random questions or practice questions that you can practice along with. And again, if you have any questions or would like further tutoring, please subscribe or leave a message in the comment section below. Thank you.